Morning, guys. It's 4:38 in the morning, West Coast time. It's 11:26 for Sunday. It's November 26, 2023, and it's a very cold. Ah, come on! Damn it. Get off my fucking head. Bug war. Yeah. Alright, these little bastards can't stand the cold temperature we've already got. Outside, well, let's see. If I was checking the thermometer about an hour and a half ago, it was reading about 28, and so far, it's 4:38 in the morning, and it's still reading about 28 to 30 degrees, which is still well below freezing. No, I'll take that back. They upped it to 27 degrees. No wonder my feet are killing me. So no wonder I gotta pull out the an old shirt that someone donated to me, and I was waiting for the right time to wear the long johns because it's colder than hell outside. But in here it's about 70 degrees, and it's tolerable, but it's still colder than hell outside. Trying to go through the YouTube and also through some of the news. News is still talking about Hamas and the ceasefire at this point over here. And I've got a presentation happening tomorrow. So I guess I'm going to have to talk about a revelation that I had earlier in the evening. And we're going to talk about it a little bit later. Now, going through YouTube, sometimes people try to pick up the most interesting topics. And I know last week I pulled up a few good beauties that really got me going on the, well, basically, they got me going on this thing. Science. Some people are like, what? Science? You can't talk to me about that one. Well, why not? Why not talk about science? Science scares the hell out of people because they don't understand it and they think it's political. But simply, science was never political. People just made it political. Wanted to make it a political head game so they can drive everybody else crazy at the same time. And right now, that's what people are still trying to do. New things are coming out every single day in science. They got magazines, periodicals, reviews from other scientists crisscrossing each other, trying to make sure that everyone else is on the same page, or maybe they got a different idea. So they decide to go head to head or try to collaborate with it. I came across this one particular astrophysicist. Her name is Dr. Becky. And Dr. Becky is an astrophysicist based out in the University of, where the hell was it again? Oh, yeah, it was back east. It was University of Oxford. Oxford. England. Cheerio. She had written a few books. One of the latest ones she wrote was A Brief History of Black Holes. And in this particular book, which I haven't read yet, she was talking about it in her videos concerning about the dynamics, anything and everything related to black holes and how they start up. One of them that one of the concepts she threw out to the public here is something about direct compression, I think. There are things I understand about black holes, and I know there's a hell of a lot more out there than I understand. And when I have one particular scientist throwing a curveball at me, I really have to find out more and more what she's talking about. They're detecting with the telescopes that they have for the Chandra. We've had out there for about 10, 15, launched up in space. We had the Hubble out there for about 20 to 30 years because of the SGS system. But now we got the JW um, satellite out there, I'll call it, taking up more and more information. And it's really interesting, all of our astrophysicists out there who are interested in cosmology and not to mention in black holes. One of the articles she was trying to post on there, and I'm still trying to get information about, is how black holes are created. She has a love affair of this one. She's really exciting here, and you probably don't even understand what the hell she's talking about half the time in the first place. I mean, hell, it's like you wish you had Carl Sagan to give a translation, but sometimes you just have to go with the flow. What I'm trying to figure out, what she's trying to say, is there are different correlations concerning about how black holes are made. Now, what we understood about science is black holes are created out of collapsed stars. With enough gravitational weight crushing into a star, even a neutron star, it creates a black hole of a certain mass. That's what we understood. That's what we learned about in college. That's what we learned about in high school, growing up as a high school during those days. But now, I'm still trying to find more information about this one here. Because somebody had posted in the science journals about another correlation of how black holes are created. And this drove me nuts. This drove me nuts on this one here. Yeah, I'm just looking through my pages right now on this one here because I need to get the. Okay, that's what it is. A direct collapse. You have no idea what the hell I'm talking about, neither do I. A direct collapse black hole. Back in 2003, and I'm going through astronomy.com on this one. A couple of scientists came up with an idea concerning about a supermassive seed black hole. You know, when it gets when you get older and older, to get more and more information concerning about things that you studied, and you find out you're more dumber and dumber than you thought, like I am, because there's more to stuff that they keep discovering, and it's weird. But for them, a seed black hole is like when you have a bunch of collected gases and they start to form a black hole. Of course, they're saying that they needed highly luminous quasars detected in the area or something like that. And they know that supermassive black holes weigh about 1 million of our sun's mass. But what they can't explain, if it is going to be something like that, just how does the collected gases have that much gravitational pull that they can actually create a black hole? I could never figure that one out. I mean, I'm going through some of the information they've got on here, just scanning my eyes on this stuff. But what they don't tell me, rotation of a black hole, and not to mention we're talking about a physics situation here where you got, uh, if you ever, okay, try this one. Fill up a tub full of water. You got it plugged in. Fill the tub with water. Then you uncork it. And then you see the vortex. What's driving the vortex is gravity. Water is being held down by gravity into the tub. When the plug is not pulled, it's just sitting there, right? But we know about Brownian motion, and things are still moving around in there. Things are not always still. Maybe looking placid, maybe on the top, almost. But you know, molecules are still flying around left and right, so you got the Brownian motion left and right. And you pull the plug, and then you see the gravitational pull really taking into effect because now the water has an exit, and you see the cyclone effect. It's pretty cool. Whirlpools. When you see those things in real water action, when you see them out in oceans, they do have currents running against each other, and they'll make that cyclonic spin. Much like in our atmosphere itself, that when we have thunderstorm activities and we have two major storm fronts kind of colliding with each other, we have air masses trying to mingle with each other, and somehow they make this kind of cyclonic effect going on. And in the process, in the lower levels of the storm systems, it's twisting to where we have a cyclone. You got your tornado on the ground. Similar effect to water is, except in this case, it doesn't do the oscillation and then turn into that. No, it just turns into that because you got cross currents forcing that. So it's pretty weird, fascinating, but weird. So now we've got in deep space, we have all this astronomical stuff out there. We got planets, we got stars. Planets are just collections of all the material being gathered, collected, compressed into floating rocks with atmosphere if we're lucky enough. Or maybe not. But they're pretty cool to look at anyway. And one of those rocks in space we live on, called planet Earth. We call it planet Earth. Somebody else might call it something else. Terra firma, maybe? Sol? I don't know. But we live on this collected rock. And we see the universe around us. We see how things are working out there. We're still scratching our heads on how everything else works. We have our own interpretation of what laws of physics on our planet and outside. So we have a general idea how things work, and then we're surprised that, wait a second, we got to correct that. So now, there were projects happening within the past 20, 25 years within that time. And they're still looking at stars beyond what our own borders are, beyond our local group and beyond the mega clusters we see out there. And with the telescopes that we have, Hubble can't even get that distinction, but it tries. So now we have the Chandra X-ray, and we also have the JS Hubble. No. Webb. That was it. JW Webb. So the Webb telescope does the infrared. Combining information together, you get a picture of what the universe beyond our own reckoning looks like. The oldest forms of it. Keep this in mind. The information we're seeing, the sources are coming from billions and billions of light years. Long ass distance, taking long ass time. So by the time we see it, we don't know if it's still there or not. But what information we do have is what we're observing at this point. And the scientists are still trying to observe things that are maybe happening beyond our own border that we can't see and that we don't understand. How does a supermassive black hole exist? Well, hell, we got black holes in most galaxies anyway. You see the cyclonic effect in them, measuring the stars' movements and the galaxies' spin, not to mention if they're being shoved towards us or further away. And when we discovered that there's a red shift and a blue shift, a red shift meaning everything's being moved away and blue is closer. It's light waves. It's light waves. So I remember watching on Cosmos. Carl Sagan was doing this 12 to 13 episode thing on PBS. Long time ago, back in the 70s. And he was talking about it. He also talks about it in his big book, too. He was talking about how light is perceived to us. If I'm not mistaken, there was, I think Lowell Observatory did that kind of experiment concerning about light waves. That you observe something closer to you, it seems like you have a bluish tint if it's especially rushing at you. Especially if you have a evil Knievel on a bike, hauling ass. You hear it, you hear the engine whine, but it sounds so compressed. It sounds so compressed because the light is being compressed on you. You're seeing this thing coming at you at hypervelocity speeds. So no wonder you've got this different perspective visually and acoustically through your ears. And then he passes you. At this point, you've already felt a rushing wind, get knocked down a bit, or maybe you're off to the side where he's just whoosh. At that moment, he was already a blue shift coming at you, according to a light wave, according to theories about this one. He leaves you. He's a red shift. He's speeding his ass like crazy. His speed's got nothing to do with you being an observer. He's just barrel assing. But we look at the sky. We see the blue and red shifts. If anything's coming at us, we would see it. We would also see light refraction from different sources, light being bended left and right because of gravity and because of masses out there. Light's treated as a particle and as a wave, I discovered. And at this point, we always see everything else being shoved away from us, as if we're the leper in the galaxy, or actually in the universe. But no, it's just how it is. Big Bang happened, and everything was just in a rush. Coalescing, condensing, creating, and recreating itself. Not to mention turning the whole universe into Swiss cheese. Ugh, God, what a thought. Yeah, it's a thought. I need hungry. I'm food. Don't mind me, I gotta get some fuel going on, so I won't put you on pause while I stuff a banana down my throat. Okay, well, had bananas. What I was trying to find out is something that was going to help me out regarding explaining all this, because after reading what even Wikipedia's got on there, it sounded like gobbledygook. Now, for a guy like me, I don't like reading gobbledygook. I like to get some kind of explanations, but when they start getting into scientific explanations, it goes over my head. I'm like a common layman. I'm trying to struggle with what the general information, what the general gist is. You're going to tell me about a star collapsing into a black hole. Okay, fine. But is there sufficient enough mass for this thing to actually do so? And what they kept calling about a direct collapse black hole, they said it was one of the rarest things out there in the universe that they wanted to get verified. They wanted to see this thing somehow, to understand it. And I'm scratching my head on this one because I understand gravity has a way of changing things and warping matter. Even when you have a planetary body, it kind of changes the relativity of time around you. It changes things around you. Larger the mass, the more gravitational curve you got there, and okay, it screws up time a little bit. Okay, we've got that. But when you have a collection of gases that are still swirling around, probably because of the motions of the molecules themselves and the atoms and the subatomic structure there. Uh, they say it creates the gravity, but I'm like, whoa, wait, where's the mass? See, that's. I look at the equations and I'm thinking, is there enough mass in a huge nebula of sorts, a galaxy of sorts? They hadn't formed any stars or anything else like that. Would it have been enough to collapse space time enough to create this vortex. I don't know where the hell they're getting this information from in the first place. I mean, I'd really like to go back into an astronomy class and talk to a professor about this. Now, I got a math professor who's interested in numbers. He's not an astrophysicist. He's nowhere near that one, but I'll be surprised if he was one. And maybe I could pick his brain cells on this one, because I want to find out about a direct collapse black hole. I need to understand this because I want to see if we've got anything similar to that. I mean, I know we got massive black holes. I know we got supermassive black holes. In galaxies, we get X-rays like them like crazy. There's a Cygnus X1 that was made famous a long while ago, and I think it's the one right by our galactic center, our Milky Way galaxy. Things like that interest me because they also scare the living crap out of me too. They can't move. They don't move. You have other black holes out there that do move. Smaller ones, probably the mass of the sun, sucking up things. When you have a solar system size, such as our system having that kind of a size of a hole, that scares the hell out of me. I keep seeing these scientists looking at all the red shifts left and right, but you know what scares the hell out of me? It's when you have a potential black hole coming towards us. A blue shift. That means we would have a mass coming towards us at an unknown speed, at an unknown rate, with a gravitational hunger. It always freaks me out every time I keep studying astronomy that one of these here days we're going to get into a black hole, but we're not. At least not in my lifetime anyway. There's still so much fuel in our own star, and they feel it's not big enough for this. There are other stars that we've already noticed thousands of and hundreds to thousands of light years away from us. There are potential. They happen to go into a supernova, we're going to know about it. But it'll take us years before we get that information. When it happens to them, that's like instantaneous, but it depends upon the distance we've got, how much time it's going to be. And we'll be seeing it, and we'll be recording it. We've already recorded millions of light years away that there had been supernovas happening in Andromeda Galaxy. They got them recorded millions of light years away. It took them millions of years in our time for the light to get to our own eyeballs so we can actually see the thing. But here's the thing concerning about a black hole. We won't know about it until we see the gravitational lensing, meaning light being refracted around the damn thing. Whether or not it's moving or not. We can see differences and subtle shifts of stars, of space around it warping a bit, just by how the light is being reflected back to us, if it's being curved in one way or another. And if the shift is pushing away from us, just static right there, and we'll see it by redshift anyway. Or, and what scares the hell out of me, is a blue shift. But they hadn't seen anything. They hadn't detected anything. There's nothing out there yet. That's a good thing, because it means I get to live out the rest of my life, mortal as it is, and just to enjoy the view before, well, before. So that's a good thing right there. But it was something that was bugging me this morning because I wanted to get a final topper on my project there. See, I do keep track of science. I just may not be able to be hip on some of the equations that they've got out there, or the high-end explanations that they try to tell people. If you're really in academia and you're into astrophysics and astronomy, you can understand it a little bit better. Me, I'm not. I just have a little interest in it, that's all. But not to the point where I'm going to be delving myself into math formulas all the damn time because I don't know what the hell they mean. They can throw out the EMC, E equals MC square, energy equals mass, and or something like that. I hear about it. I just look at it like, you got to be kidding me. What is this again? E equals MC. Well, okay, so throwing out the E equals MC square. It's energy equals mass times the speed of light squared. You gotta love Einstein and his theories on this one because he was really hip on that stuff. You think from a simple patent clerk that he'd be just a simple patent clerk, but you didn't realize what kind of a sharp mind Einstein actually had. Coming up with theories and ideas that are still being put to the test. Even he dabbled into the realm of quantum physics. To this day, we're still going beyond that. But it is something to think about. Unless, of course, you're going to be a guy like me who's going to be thinking about budgets and checkbook and how things look. Things look pretty. Okay, they got pretty patterns left and right. I know some people are like, so what? All right, so what? We got repeating patterns in the sky. We got repeating patterns in different forms and functions. So what? We even do it ourselves artificially. So what? When math doesn't entice and excite people, even the youth, we got a problem. We can put on a screen. We can put on a movie screen or a television screen of images that we create or see somebody else create. Do you realize the energy is coming through into our eyeballs at a certain speed of light? A certain fraction of a second? Not to mention the energy going through the electronics, the microchips, the digital front ends, the zeros and ones traveling at a speed that we don't even comprehend. How's that for mathematics? How's that for thinking about math? And it's nerve wracking for a lot of people because they can't understand it. Neither can I, but I can appreciate it. I can look at it and just enjoy it. The lights, the energy emanating from the light above, that can be calculated. Knowing the right formula for that one, that's calculable. How much BTU energy that you're using out of a gas burner? It's calculable. That's how come you get billed left and right on your energy bill. And how much wattage I'm pulling out from a light bulb translated to how much money I'm going to be paying. Math is everywhere. We may not understand it, but math is everywhere. If we can't understand it, maybe we'll have a better understanding of this planet or the universe itself. Then again, I'm still waiting for a black hole to suck us all into non existence at that point over here, crush us into a naked singularity, and we won't be anything left but until subatomic particles, or maybe beyond that. And if we happen to get redigitized somewhere else, I don't know about that because I think I'll already be non existent at that point. Something to think about for a Sunday, ain't it?